In the last video lecture, we have solved some problems based on Thevenin theorem and superposition theorem. Today also we'll see some problems and we'll finish this chapter. So here we go. We'll start with the 11th one. They're asking for the circuit in the figure, find the Thevenin equivalent between the terminals A and B. Here are the two terminals A and B. And our task is to find out the Thevenin equivalent circuit across A and B. It means at the final stage between A and B, you have to find out Thevenin equivalent circuit. What Thevenin equivalent circuit says, you need to find out the voltage, that is the Thevenin equivalent voltage, and the current, that is the R equivalent of the circuit across the A and B, or resultant resistance of the circuit across A and B. So here they are saying find out the Thevenin equivalent between A and B. It means we need two things, VTH as well as RTH. So first I'll calculate RTH, okay? And I think you people know what is the procedure to calculate the RTH. Yeah? The procedure to calculate the RTH, I have to turn off all the independent sources. Remember, not dependent source. Though we don't have the dependent source in the circuit, we are having only independent sources, voltage source, and current source. So as you know, to find out the resultant value of the resistances, we have to turn off the all independent sources existing in the circuits. So for the voltage source, again, I'm telling you, for the voltage source, we have to short the circuit, right? For the current source, we have to open the circuit, right? This is the procedure to turn off the independent sources. Here, I'll turn off this by opening this from the circuit. I'll turn off this by shorting it. I'll turn off this independent voltage source by shorting it. Now, your resultant final figure is like, here I'm drawing. This short circuited terminal A, B is over here, and this is given as A and this is given as B. Now come to the point, and the point is here, this is 10 ohm, this source is shorted, okay, fine, and here again 10 ohm resistance is connected, and here we are having only 10 ohm, because 5 ampere current source is turned off from the circuit, right? So the values are given over here. This is 10, this is 20, this one also 20, 10 and 10. Now see friends, across A and B we have to calculate the RTH, right? So these 2 points will be constrained in the circuit. Okay, we have to keep this point as it is, and then we have to calculate the value of resistance, right? So this 20 and this 20, they are connected in parallel. 20 and 20 are connected in parallel, so the resultant is 10 ohm. Why? Because 20 into 20 divided by 20 plus 20, it means 40 2 and this is nothing but 10 ohm. Okay, so can I replace these two by a single branch over here? Wait a minute. I'll remove this branch, and instead of this branch I'll be having a single branch that contains 10 ohm resistance. Is it okay for you? Now see, now you can't say this 10 ohm and this 10 ohm, they are in series. Why? Because the point B is existing over here, and we discuss about the series combination of the elements. Whenever if we are having the third branch in between two resistances, they are no more connected in the series connection. Is it okay to you? So this 10 and this 10, they are not connected in series, and they are not connected in parallel combination also, because starting point is same but ending point is not same. What about these two? What about these two, 10 and 10? They are also not connected in any combination. This one also. So here is the condition where no one is connected in series or parallel. So we can apply the, which one? delta and star. Here they mentioned delta. Delta connection they have given. Okay. So can I reduce this delta into star? Yes, I can. This is the star over here. Is it okay? Now see, what is the value of this? 10 into 10. 10 into 10 divided by 30 means 100 by 30. 100 by 30. Or I can say 10 by 3. So these all branches will be having 10 by 3, 10 by 3, 10 by 3. Is it okay to you? Because the values are same over here, that's why all values will be 10 by 3, 10 by 3. Again I'll redo it, don't worry. Fine. Okay. So our resultant circuit is like this. It will be connected over here. This is the point A. The value of this resistance is 10 by 3. Here also 10 by 3. Here also 10 by 3. Now see friends, this 10 by 3 and this 10, they are connected in series combination. So the resultant is 10 plus 10 by 3. It means 40 by 3. Is it okay? So this branch I can replace with 40 by 3. Fine. This entire branch I'll replace with single element, single branch, and the value of that is 40 by 3. Okay, I'm doing this for you. This is 40 by 3. And this is like this, 10 by 3. This is 10 by 3 already given. So now see, this 10 ohm and this 10, they are connected in series. So again, the resultant combination of this is 40 by 3. So this is nothing but, this branch is nothing but 40 by 3. Now this 40 by 3 and this 40 by 3, they are connected in parallel combination. So the resultant is 20 by 3. 20 by 3. I can remove this branch from the circuit. I hope it is clear to you. It's very easy actually. Okay. Now the all branches is reduced in the form of single element in the branch. Okay. Now 20 by 3 and 10 by 3, they are connected in series. So 20 by 3 plus 10 by 3, the final is 10 ohm. So the resistance between this two point A and B is nothing but RTH, and that is 10 ohm. Is it okay? So for this particular circuit, you have calculated RTH, and that is 10 ohm. Is it okay? Now it's depend on you to calculate this VTH. This is your homework. Okay. Once you find out the VTH, you can easily reduce this circuit in the form of Thevenin equivalent circuit, where RTH is nothing but 10 ohm and the VTH, which you will find out. Is it okay? Good. Come to the 12th one. The question is, find the Thevenin equivalent between terminals of the circuit A and B. Where is the A and B? Here is the A and B. The question is same. We have to find out the Thevenin equivalent circuit, means for this circuit also we have to find single voltage source and single resistance. Is it okay for you? So come here. So here we are going to calculate VTH. Suppose I'll get, see, directly we can't calculate the RTH. Why? Because dependent sources are given in the circuit, and whenever we have dependent sources in the circuit, we have to follow the technique of apply one outer voltage source over here, and due to that voltage source I'm having current I in the circuit. Once I have the voltage and current in the circuit, I can easily find out V by I, and that V by I is nothing but the value of resistance across A and B. I hope this one is clear to you. So first I'll calculate the VTH over here. Between A and B, I have to calculate VTH. Suppose. What is the VTH? Simply here you can see VTH is nothing but, I assume the direction of VTH is like this. VTH is the Thevenin equivalent voltage across A and B. So the same voltage across 50 volt is nothing but VTH. Is it okay? The voltage drop across 50 ohm resistor is nothing but VTH. So can I say the VTH is nothing but this 50 into I, and remember this I direction should be from this side, that If the I direction will be this side, then only you will get positive VTH, means the drop will be like this, similar to whatever you assumed. Okay, so 50 into I. But here the current is in opposite direction. Current is coming from the downwards. Okay, so that's why it's a minus. Minus, and the value of current is 40 I naught. So finally this one is I naught. Is it okay? So you have to remove this I naught to calculate the individual value of VTH. So can we find out over here what is the I naught? Yes, we can easily find out. Here I naught is given here. For this mesh, the I naught is, tell me, 3 minus 2Vx divided by 1K. Is it okay to you? This is nothing but the I naught. When you will put this value of I naught here in this equation, you will get VTH is nothing but minus 2000. 3 minus 2Vx is nothing but 1K. Is it okay? Now see, what is this Vx, this unknown variable? We have to remove this from the circuits. Then only we can calculate the VTH. Is it okay? So see, Vx and VTH both are same thing. What is the Vx over here? Vx is given the voltage drop across 50 volt resistor, and our VTH is also the same thing. It means Vx is nothing but VTH. Is it okay? So once you will put this value over here and you will calculate VTH, you will get, let me do it for you. It is VTH minus 2, 3 minus 2 VTH. Is it okay? So this minus sign will go inside. So it will become 2 VTH minus 3. This is nothing but VTH. Now your VTH equal to 4 VTH minus 6. Is it okay? So 3 VTH. This VTH will come to this side and the 6 will go to that side, and VTH is nothing but 2 volt. So for this circuit the VTH is 2 volt. Is it okay for you? For this circuit, the resultant of this circuit I am drawing. VTH is nothing but 2 volt. Now your task is to calculate RTH for this circuit. Is it okay? So for the RTH, what is the procedure? The procedure says to find out the RTH, you will apply, what you will apply, tell me. You will apply VTH over here. One battery source and one current. Now if you are find V by I, so this V by I is nothing but your RTH across A and B. But this procedure will be lengthy here. Why? Because I am having directly current in this A and B. So I am having another way to solve this circuit. How? See here. To calculate the resultant resistance in the dependent sources circuit, the standard procedure is across the point A and B, where we have to calculate the RTH or equivalent resistance, we have to put battery voltage source V, consider the current I because of that, and V by I is nothing but the RTH in the circuit, or R equivalent across the A and B of the circuit. But another way we can solve this. You already found the open circuit voltage between A and B. That open circuit voltage is nothing but VTH, 2 volt. Now if you will find the short circuit current over here, the short circuit current over here, let's say is ISC, the short circuit current. Now if you will calculate VTH by ISC, VTH by ISC, so it will be your RTH. Is it okay? So can we calculate ISC very easily? Yes, I can. See, once you shorted A and B, it means the voltage across this is 0, and I told you earlier, whenever you short 2 points, between those 2 points, if you are having any resistive branch, so that will be invalid, dead now. Okay, there is no importance of this circuit. Or in other way you can understand, this current is coming over here. Here the current will follow the minimum resistance path always. Here the resistance is 0, so entire current will go to the ISC in this branch, short circuited branch, and your current is nothing but ISC is nothing but, you assume in this direction, but current is coming from this direction. This is nothing but 40 I naught. For the direction of current you can say it negative. What is the I naught over here? I naught is nothing but, here again I naught you can calculate 3 minus. What is the value of Vx? Vx becomes 0. Once you shorted this A and B, your Vx is nothing but the voltage across here. Is there any difference now in between these 2 points? No. So what is the Vx? This minus this, both are same, Va minus Va. It means it's 0. So Vx is 0. We sorted it, that's why Vx becomes 0. 3 minus 0 by 1k. So this is nothing but 3 milliampere. So I naught we have minus 40 into 3 milliampere. Is it okay? So this is nothing but 0.120. I hope it's clear for you. Now come to the RTH. RTH is nothing but 2 divided by 0.120. Is it okay? So take this here 0 and 0. So this is nothing but 200 by 12. This is nothing but your answer. Is it okay? This is the very simple circuit actually. And this type of questions we are basically getting in the GATE examination. Actually, they ask always dependent source based problems in the exam. Okay, why? Because the dependent source problems become tricky and lengthy sometimes. So people avoid this type of problem. So they also ask the same problems. Okay. So you can see nothing is here. We can easily solve it if the concepts are clear. So friends, again I'm saying to you people, please solve as many problems as you can at your home, because it will enhance your concepts. It will, make your group over the subjects properly. Come to the next question over here. Obtain the Norton equivalent at the terminal A and B. Now, this is for you homework. This is your homework, okay. In the last question, I calculated the Thevenin equivalent circuit. Now, it's your task to calculate the Norton equivalent across the A and B. And for the Norton equivalent, believe me, this circuit is also very easy circuit and very easy problem. So, the Norton equivalent is nothing but, I'm having single current source, that is IN, in parallel with RN or RTH or R equivalent of the circuit across the point A and B. Is it okay to you people? So you have to calculate this. Okay. So this is very simple and this is homework to you. Come to the 14th one. For the transistor model in the figure, obtain the Thevenin equivalent across the terminal A and B. Where is the A and B? Here is the A and B. This circuit I'll do for you. Again, Thevenin equivalent circuit. Thevenin equivalent circuit says I have to reduce this entire circuit in single source and single element or single resistance across the given point A and B. So this is nothing but VTH. This is nothing but RTH. I have to calculate this. First, I'll calculate VTH over here. So I assume this is VTH like this. Okay. So come over here. The VTH is nothing but, see, in this entire mesh only one current is flowing, and that is 20 I naught. Is it okay? So voltage drop across here is nothing but from this side to this side. But our assumed VTH is opposite sign. So VTH is nothing but minus of 2K into 20 I naught. 20 I naught. Why this minus? Because my assumed direction of the voltage and actual direction of the voltage is different. That's why this is the negative sign. Negative sign at last, when we'll draw the circuit, we'll keep negative sign upside and positive sign downside. I hope this one is also clear to you. So this is nothing but minus 400k of I naught, equation 1. Now here you can clearly see this. We are having only one unknown in the equation. While finding out the value of VTH, we are getting I naught here. So can I replace this I node? Yes, I can replace this I node easily over here. The I node is nothing but 6 divided by 10k. It means 3k. It means this is nothing but 2 milliampere. So you'll put the value minus 400k into I node is nothing but 2 milli. Yes, 2 milli. Milli and k will cancel out. So this is minus 800. Is it okay? This is nothing but volt. So here the voltage is 800. Okay, this is nothing but 800 volt. Is it okay to you people? Now come to the RTH. See, in the last example, how we calculated the RTH by shorting it, right? Here also I'll apply the short circuit like this. I will assume the current ISC. And you remember, this entire current flowing in this mesh will now come to this short circuited path, because current always follows the path in which we are having zero resistance. Okay, so here your ISC is nothing but minus of 20 I node. The entire current is now flowing in the ISC. So now question is, what is the I node? The question is, what is the I node? And you know our I node is fixed, 2 milliampere. So this is nothing but minus 20 into 2 milliampere. Is it okay? So this is nothing but minus 400 milliampere. This is nothing but ISC. And you calculated already the VTH was nothing but minus 800 volt. Is it okay? So the RTH we can get easily minus 800 divided by 400 milli. So this is nothing but 2k. Is it okay to you? So the resultant of this circuit is nothing but a minute. Okay. The resultant of this circuit is, we are having here 2k, and the voltage we have calculated is nothing but 800 volt. But direction was negative, so better do like this. The point is A and B. This is nothing but your solution for this question. I hope this one is clear to you and you are enhancing your concepts. So friends, do the problems at your home. Again, the question number 15, find the Norton equivalent at the terminal A and B of the circuit. This is homework for you, okay? Question level is good, okay? In the GATE examination, you will get the same type of questions. So I hope you people will do this. Come to the 16, find the Thevenin equivalent of the circuit. Come to this circuit. They are asking the Thevenin equivalent of the circuit. I'll do this for you. I'll take it on the phrase page. I'm drawing this question for you again. Wait a minute. Here they have given dependent current source, and the value of this dependent current source is 0.1 of I naught. Okay, here we are having 40 ohm resistance. This is the short branch, and here we are having 10 ohm. This is 20 ohm over here. This is 2V0. Fine. A and B. Across A and B, we have to calculate the VTH. Is it okay? Now the given terms in the circuit is, wait a minute. The I naught given in this branch, the V naught is given across here, and VTH is nothing but the voltage across A and B. So friends, we have to calculate VTH. But before going to calculate VTH, think for a moment. In the GATE examination, suppose the same question is available for you. They are asking find out the VTH, Thevenin equivalent voltage for this circuit, and they have given 4 options. 2, 3, 0 and 4 volt. No need to calculate this type of circuit, because see, in this circuit, is there any independent source is given? Independent source, is there any independent source available in the circuit? Independent source means the source which provides the energy to the circuit. In this circuit, we don't have the energy source. This type of circuit called dead circuit. Dead circuit. Okay. So VTH for dead circuit is nothing but 0 volt. There is no voltage across A and B. Why? Because no independent sources is given. At any point, we don't have any voltage in the circuit. Why? Because no energy source, no energy. There is no energy source, there is no energy at the output. It means 0 directly. So you can choose the option C without thinking. So this type of circuit is called the dead circuit. For the dead circuit, we don't have any voltages or current value in the circuit, but we have RTH for that circuit. Dead circuit means the RTH is a dead material, right? Element. Resistance is nothing but the passive term. So that's why for the dead circuit, it contains only the equivalent resistance, not the value of voltage. So for this particular circuit, VTH is nothing but 0. I hope it's clear for you. Now come to the RTH. Now RTH calculation is your homework over here. Is it okay? You are having two methods to calculate RTH. Okay, one you can apply over here the battery V. Because of this battery you are having I. Now you can apply over here the nodal analysis or mesh, whatever you need to find out V by I, and your V by I will nothing but your RTH. And I am telling the value of RTH when you calculate this, it will be 39.2 ohm. Is it okay? So this is homework for you. I hope this is clear for you. Come to the next one. Find the maximum power transfer to the resistor R in the circuit. Is it okay? Where is the R? Here is the R. The question is the maximum power theorem. Maximum power theorem means we need the Thevenin equivalent circuit across R. Is it okay? Means across A and B, I need to calculate Thevenin equivalent circuit. Point A, point B. So this is the A and B. Over there we are having R. We have to calculate the value of R for the maximum power transfer. We know for the maximum power transfer the R is nothing but RTH. So to calculate the value of R, we have to calculate the value of RTH for this circuit. Is it okay? And at the final stage we have to find out the maximum power also. Okay. So here I am going to calculate this. So to calculate the Thevenin equivalent voltage, we have to open this load circuit or load element from the circuit. So here the voltage is VTH. Here the voltage is VTH. This is nothing but the voltage across this point. Means this point. These two are same. Okay. Here I am having the voltage V0. Over here I am having V0. So can I apply here nodal analysis? Yes, I can. So by applying the nodal analysis at this point, I am having the equation V0 minus 100 divided by 10k plus V0 divided by 40k plus V0 minus VTH divided by 22k. Is there any other branch over here? No. Only 3 branches. So 3 terminal equation equal to 0. Equation 1. The next one is over here. The VTH minus V0 divided by 20k plus. For this VTH we are having 3 branches. 1, 2, 3. This branches is not connected. This is the open branch. Dead branch, right? So we are having 3 terms only. From this we are having 0.0003. First take this this is nothing but VTH by 30K. And this is incoming current. Incoming current we take negative 0.003 V0 equal to 0. Now you are having two equations and two unknown V0 and VTH. But we are interested to calculate VTH only. So when you solve these two equations, you will get VTH is equal to, this VTH will be minus 243.6 volt. And when you will calculate the RTH, so RTH will be minus 1.3636 K. Why we are getting this minus? Resistance, the value of resistance is minus because of this dependent source available in the circuit. Because of this, I told you in earlier classes also, whenever we are having the dependent source in the circuit, we can get the value of current as negative. Okay, because the presence of dependent source makes the circuit active, and for the active sources the value of resistance is nothing but the negative. Is it okay? So this is the circuit for you, resultant circuit, where you can see VTH and RTH. Once you calculated the RTH, the R is nothing but 1.36K for the maximum power. Okay. Is it okay for you? So your resultant circuit is 1.36K, and this is nothing but 243.6. Negative means you have to change the polarity like this. This is your load resistance and value of load is 6 ohm. Is it okay? So you can easily calculate the value of power. Okay. So this is all about the maximum power based problem. Come to the next one. In the next one they are saying, determine the maximum power that can be delivered to the variable resistor R in the circuit. Where is the variable resistor? Over here. Okay. So can we calculate VTH and RTH for this circuit? Yes, I can. I can calculate. I'll open this. Yes, I opened this like this. Fine. First I'll calculate the RT. Oh, no need. First calculate. Okay. You have to calculate VTH and RTH because you have to reduce this circuit in the form of single source and single resistive element. Fine. A and B. Here is the point A and B. So RTH. So how to calculate RTH? To find out the RTH, I have to turn off the all independent sources working in the circuit. So here I am having 60. So this 60 will be short circuited. So your resultant circuit or reduced circuit will be like 25. This is 10, 20, and this is 5. This is the A and B, over which we have to calculate the resultant. These 2 points are short circuited. Is it okay? Short circuited like this. Is it okay? Short circuited means what? This point and this point both are same thing. Point A, take this is A and this B, both are same. Same means I can redo this circuit like A, B, here I am having 20 ohm, here I am having 5 ohm. Between these points, suppose this is C, this is D, C, D. C and B, I am having 20. Okay, fine, this is B. Now C and A, the A and B, both points are same. So here I am having the same thing like this. This is nothing but 10. Over here also I am having the 25. Is it okay for you? Because of these 2 points are short circuited, they are become one only. So once they have become one, these 2 branches become parallel to each other. So 10 and 20, they are connected in parallel. So the resultant is 10 into 20 divided by 30. Is it okay? So this is nothing but 20 by 3. What about this 5 and 25? 5 into 25 divided by 30. Is it okay? So this is nothing but 125 divided by 30. Okay. So this is 125 by 30, and these 2 are in series. So finally 20 by 3 plus 125 by 30. It means this is 200, this is 300. So finally you are having 325 divided by 30. So this is nothing but value of resistance RTH over here. 325 divided by 30. 325 divided by 30. This is nothing but your RTH. You can divide it by 5. 5 6 ja, 5 6 ja, 5 5. 65 by 6. This is nothing but your RTH in ohm. Okay. Now you can calculate VTH also over here. The VTH. Tell me the value of VTH. Okay, I'll do it for you. To calculate the VTH, the procedure is, this is 10, 25, 25. This is open, okay. And here I have to calculate VTH. Here you are having 60. Is it okay? So can you find the resultant current first? Yes, I can find out the resultant current. How? Because this, see, 25 and 5, now they are connected in series. This is not point, this is an open circuit now, okay. I am not considering this point at this moment. Later I will consider it, but here to calculate the current, this current, I am not considering this point. That's why this 25 and 5, they are connected in series combination. Is it okay? So this is 25 and 5, this become 30, 10 and 20, this become 30, 30 and 30, they are connected in parallel. So resultant is 15, so 60 by 15 is nothing but the 4 ampere. This is 4 ampere. Now 4th ampere current is coming from the source. Here the current will divide. Here the current is getting 30 ohm, here the current is getting 30 ohm, means current will be divided into the equal amount. So here we are having 2 ampere. In this branch also we are having 2 ampere. This 2 ampere is current coming over here. So here I am having the drop is 10 volt in this direction, plus minus. Here I am having 2 ampere is coming. Here is 40 volt. Here is the 40 volt. Now if you will observe this circuit carefully, so across this you are having 40 volt, sorry. Here this is the point. Over here you are having in this direction 10 volt, and here you are having VTH plus minus. So we can apply KVL over here in this circuit, and we can get VTH. How? I'll start from here. I'm getting minus VTH. Fine. Move forward, and this is minus 10. Come here, and this is plus 40 equal to 0. So VTH is nothing but 30 volt. Is it okay? So for this circuit, the resultant is, wait a minute. So for this circuit, the resultant circuit is this was nothing but 65 by 6, and VTH you calculated, and the VTH is 30 volt. Did we calculate 30? Yes, you can check, okay. This is 30 volts. So this is the resultant. Is it okay for you? So this is the circuit, and he is asking determine the maximum power that can be delivered to the R. So what is the R now? Load resistance should be equal to the 65 by 6. Here the 65 by 6 is another resistance. Now we can easily find out the maximum power. So this is up to you to find out. I hope this one is clear to you. Come to the next now. Find the maximum power that can be delivered to the resistor R in the circuit. Where is the R? Okay, here is the R. Again, the maximum power theorem. This is the very important theorem. Again, this question I am doing for you. Please observe it carefully. He is asking for the maximum power that can be delivered into the R. He is not asking the value of R, but asking for the maximum power. But to calculate the maximum power, I need the value of this R also. So simply I can say I need Thevenin equivalent circuit. then I can proceed by the maximum path here. This is the point A and B. Over here the point is A and point is B. I need the terminal also, RTH, and this is the VTH. I need to calculate RTH and VTH as well. Okay, so first I'll calculate the RTH. Suppose for the RTH I need to turn off the all independent sources working in the circuit. Here I'm having the voltage source, I'll short it. Here I'm having current source, I'll open it. Here I'm having the independent voltage source, I'll short it. So my circuit is become like, this is the open branch. So this 5 and this 3, they become, this 5 and this 3, they are connected in series. So your circuit is like, this is R, and we have to remove this R actually, because this is the open circuit equivalent resistance kind of thing. Wait a minute. It's like, this is the point A and B. Here I'm having 8 ohm. Once you turn off the circuit, this 3 and this 5 will become in series connected, and over here I'm having 2 ohm. Is it okay? So finally the resultant, you need to calculate RTH, and the resultant is the parallel combination of 2 and 8. It means 2 into 8 divided by 10. 2 5s, this is nothing but 8 by 5 ohm. This is 8 by 5 ohm, your equivalent, R equivalent for this circuit. 8 by 5. Correct? Now you need to calculate the VTH also. What is the VTH procedure now? I have to open this and have to assume here VTH. Over here I have to assume VTH. Now your circuit will become like, wait a minute, your circuit will be like 2, 10, 5, 6, 3, 20, and we can stop over here. This is VTH. Is it okay? So for this particular circuit I can apply over here the source transformation, and this 5 and 6, the combination of parallel resistance and current, I can convert it into equivalent voltage source, and that is 6 5 jar 30 volt in series with 5 ohm. So I'll reduce this branch. Oh, sorry. This is 2 ohm, 10 volt. This will be reduced, like the direction will be this side, that's why current will be in this way. 30 volt in series with 5 ohm. Here this is 3, here this is 20, and here is my VTH between these 2 points. Is it okay? So get the current first in the circuit. This is the open one, this is the open branch, right? So get the current first and then we'll get the VTH. Here this is the current in the circuit, and this current is nothing but, this I note is nothing but 20 plus 10, and this is 30, this is also plus 30, divide by series resistances 5, 5, 10. So this is nothing but 20, 30, 50, 10, and this is the 6 ampere. 6 ampere is the current flowing in the circuit. Now here is the 6, so this drop is 18 volt. Fine. Now we'll jump to this circuit plus VTH, because we have to calculate VTH. Over here again the current is 6, so here this is 30 volt over here, right? Is it okay? And the direction is like, now in this circuit, in this mesh, this one, I can apply the KVL over here. So I'll start from here. This is minus 18 I'm getting. Here I'm getting minus VTH. I'm coming to this, I'm getting minus 30. Here I'm getting again minus 30. Sorry, here I'm getting plus 30. Here I'm getting minus 30. I'm coming to this side, and at the end I'm getting plus 20 equal to 0. So finally, this 30 will cancel out. Finally, VTH is nothing but 2 volt. So for this circuit, VTH is 2 volt. Is it okay? And you already calculated the value of RTH. RTH was nothing but 8 by 5, and for VTH you calculated 2 volt. Now this is your load resistance R. So for the maximum power, this R will be 8 by 5. Now can you calculate the maximum power P max? 4 VTH by 2 RTH. Sorry, don't remember this formula. You can first find out the current over here, I, then power is nothing but P max is nothing but I square R. Is it okay? So this is the procedure to find out the power P max. Now see friends, in the last question, find the Thevenin equivalent circuit for the network external to the resistance R. Here, across this, I have to find the Thevenin equivalent. So friends, this question is homework to you, and I hope you will solve it, and your concepts, you clear all your doubts and enhance your concepts over the circuit theorem. So friends, in this entire chapter, we have discussed maximum power theorem, superposition theorem, Thevenin theorem, source transformation, and Milliman's theorem. So apart from this, we have solved some problems also based on gate and gate level problems. Again, I'm telling you, for the practice, you can refer the book Alexander and Sudoku, Electrical Theory or Electrical Circuit. So friends, do the problems, enhance your concepts over the subject, and we'll meet in the next video lecture, and we'll start the next unit, third unit, that is the transient analysis. So we'll meet in the next class. Till then, take care and bye.